The last section is on loan repayments. So long-term loans such as housing loans are usually paid off in regular instalments, with compound interest being charged on the balance owing at any time. The calculations associated with paying off a loan are therefore similar to the investments in the calculations in the previous section. So we are going to be doing, looking at each instalment and making a series out of it. There is a couple of different ways that you can do this. I'm going to show you my preferred method. Question number 1. A person borrows $7,000 and agrees to repay it over 4 years with equal monthly instalments. So as soon as I see that word monthly instalments, I know that I need all my units to be in months, which means the 4 years is 48 months. And I need to check my interest rate as well, but it is 0.75% per month, so it's already in months. Find the amount of each monthly instalment. Now, slightly different to when we're doing superannuation. When I do A1, this is going to be the amount that is left at the end of the first month. Okay, and we're going to be building on the series as we go into the A2, A3. All right, you'll see what I mean. So in the first month, the person has borrowed $7,000. They are going to get charged compound interest on that, which means I'm going to be timesing that by 1.0075 because that was a percentage. I had to divide it by 100, and I've added on the 1 from the compound interest formula. Okay, as I said, this is only for the first month, so that's going to be the power of 1, because only 1 month has passed. And at the end of that month, this is why I have to set it up differently, because at the end of that month, the person has to make a repayment. And we're using M as our repayment, our monthly repayment in this question, which is what we're going to be trying to find. All right, when we move on to the second month, whatever we had at the end of the first month is what we have to start with in the second month, right? So we're starting with the 7,000, 1.0075 minus M. That's what I've currently got. Don't know what it is because I don't know what M is, but that's what I've got. Then we have to pay interest on that. So I'm going to put all of that in brackets and times it by the 1.0075 because that's my compound interest part. But then guess what happens? We have to make another repayment. So we subtract another M off the end of that. Now, you'll start to see when you build these. I'm going to expand it and it will become a square. Yes, I'm going to get to that. You'll start to see that as you build these, there is a pattern that's always going to come out of it, and you probably will start to skip a few steps. But because this is our first one, I want you to see how it's actually working properly. I want to do all the bits. So what I'm going to do is I'm going to times this 1.007 into the two terms. There's two terms, that one and that one, inside the bracket. When I times it to the first one, I get 7,000, 1.0075 squared. When I times it with the M, I get minus 1.0075 M, and then my other little minus M sitting on the end. Now, often I would only just do 1 or 2. I might even stop there and get my trend from there, because it's our first one. Let's do the third one, just for practice. A3, we would start with the 7,000, 1.0075 to the power of 2 minus 1.0075 M minus M. And then all of that has to get times by the interest rate again, which is 1.0075. And then you would subtract off yet again another repayment. All right, now let's times this 1.007 into the 3 terms that are inside the bracket. So it becomes 7,000, 1.0075 cubed minus 1.0075 squared M minus 1.0075 m minus m. And what you will hopefully see, the more terms that we do, and you really don't want to go much further than 3 because you're just getting messier. But what is happening is every time we do another month, this term out the front, this bit out the front, every time it's just getting an extra power. So third power of 3. Okay? But the series that is building is happening here with all these m's. We've got squared, power of 1, and that will just be a 1 there. What we're going to do is factorise the m out of it and see the series happening just with the numbers. Okay, it will look like this. So factorise out a minus and an m. And one of the tricks that we always like to do is to reverse our series so that it's from smallest through to largest. So the first term will actually be the 1, then the plus 1.0075 plus the 1.0075 squared. Okay, so I'm really doing that one and that one and that one, going in reverse. Okay, so you can see, hopefully you can see now, very nice little series happening in here. We can now generalize this, so I used to do a little down arrow here, but that pattern is going to continue the whole way through until the end of this loan, which was 48 months. So A48. So I could use this pattern that I've made to help me work out what my expression would be. This first part, that number there, is going to become a 48. So it'll be 7,000, 1.0075 to the power of 48, minus m. And then this series that's in the bracket here, it's still going to be 1 plus 1.0075, and then it would be plus 1.0075 squared, plus 1.0075 cubed, plus all the way up. How far is it going to go? 1.0075. What's its power? 47. Very good, because the first one, the power of 1 is there. This one here is the 48th one. Okay, so that will be a power of 47. There is still 48 terms in there. You can see the 48 terms? Yes? So this is your power of 1 through to 47, and that's your 48th term. Okay, so now, if this is a loan, at the end of the 48 months, we certainly hope that we've paid off the loan. That was the goal, right? It says in there that we paid back the loan after 4 years, which means at the very end, A48 must be equal to 0 because we paid it off, which means that if A48 is 0, the only unknown in this equation here is the m, and I can solve for the m. I just have to sum a series to do it. Okay, so let's put this in. I'm going to go 0 equals 7,000, 1.0075 to the 48. I probably could have moved that over straight away. I would normally do that to save myself some writing. Okay, so what I'm going to do is I'm going to take this whole part here that is negative, move it across the other side to make it positive. So there'd be an m over here. Okay, now before I divide this series across, I'm going to sum this series. It's a geometric series. A is 1, R is 1.0075, and N is 48. 48 terms. So my formula is AR to the N minus 1. So A is 1, R is 1.0075 to the power of 48, minus 1 over R minus 1. Same formula we were using yesterday. Okay, so the one at the front here isn't really doing anything. This on the bottom, I can just subtract the 1 off and it would be 0.0075. So what I will do is starting with my right-hand side here. I would times the 0.0075, that was the denominator, times it over to the other side. So that's just this part, when I subtracted it, I've just times it over here. But then the part that's on the top, I'm going to divide it underneath. So it'll be 1.0075 to the 48 minus 1. And then you have the joy of typing that in your calculator. Now, sometimes, depends on who's working out you're following, sometimes the temptation is to work out this whole thing here as a number first. The problem with doing calculations too early, as you know, is that if you would have to round this, it won't be a nice whole number, which means then you're bringing in rounding errors if you're using that decimal to keep going through. So it is best if you try not to actually calculate anything, until you're right at the end and you're doing it all in one hit. Has anyone got an answer? Kieran? Perfect, that's it. So every week they have to pay $174.20 and they'll pay off their loan in 48 months, 4 years. All right, let's do it again. Okay, as I said, that was me being quite thorough, showing all the steps. We can cut it down a little bit once you're a bit more comfortable with it. So let's try question 2. A man borrows $2,000 at 1.5% per month, so that's in months there, where interest is compounded monthly, so we do want it in months, on the balance owing. If he pays off a loan in equal monthly installments over 3 years, so that's going to need to be 36 months. What is the amount of each monthly installment? So we're trying to find that M again. Pretty much the same question as the last one with different numbers in it. So we're starting our process by finding A1. In the first month, there is $2,000 that the man has borrowed. He will get charged interest at 1.015. Turning it into a decimal, is that okay? And then we would subtract off a repayment, because he makes a repayment as well. He gets charged interest and he makes a repayment. We go into the second month, which starts with what we had at the end of our first month. So there's my starting point. I times it by my interest rate again and subtract off another payment. When we expand that through, we get 2,000 1.015 squared minus 1.015 m minus m. We might just stick with 2 this time, we don't have to always go to 3. Sometimes in questions they'll specify how many they want you to do. So what I'll do is I'll factorise the m out so that I can see the series that is happening. So minus m, and then remember start with the 1 plus the 1.015. Okay? You might even be able to, without having to actually expand it, A3 would be 2,000 1.015 cubed minus m bracket 1 plus 1.015 plus 1.015 squared. That's the pattern that's happening. I did that without expanding because I can just see the pattern that's building in there. Okay? Then I know that I have to follow through that pattern for 36 months. So A36 would be 2,000 1.015 to the power of 36 minus m 1 plus 1.015. Then I'm just going to go plus dot 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 dot, because we know that's going to continue until 1.015 to the power of 35. Okay, so remember that A36 will be equal to 0 because we've paid off our loan at the end. And this time I'm going to move this part straight across the other side. Okay, so it'll be m bracket 1 plus 1.015 plus dot 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 1.015 to 35 equals 2,000 1.015 to the 36. Okay, so we've kind of isolated our series over here on the left, so let's use our formula to sum our series, leaving the m there. A is 1, R is 1.015 to the power of n, which is 35 terms, minus 1 over R minus 1. That's your sum formula. Okay, so to get the m by itself, the denominator is going to times over here and the numerator will divide underneath. So it's 2,000 1.015 to the power of 36. I'm going to times by 0.015 and divide by the 1.015 to the 36 minus 1. I don't technically need those brackets on the bottom there, but anyway. Does anyone go on and type that in? So I got, and hopefully you get, 72.30. Excellent. All right. Is it getting easier? We got one more. Question 3. When Justin borrows $8,500 at 12% per annum over 5 years, he does not have to make any repayments for the first 2 months. Ooh, spanner in the works. Okay, so no repayments for the first 2 months, but they're broken into parts for me to help. How much does he owe after 2 months? That would just be, this is just straight compound interest, so A in the compound interest formula equals 8,500. Wait a second, I didn't change this. 12% per annum, what's that in months? 1% per month. And 5 years is 60 months. We will, yes, when we do the big series part, yes. But for the first 2 months, there's no repayment. So I'm just going to do the compound interest formula for 2 months. Because you've got the loan, you're still going to have to pay interest, I'm sorry. Even though you're not making repayments, you still have to pay interest. So it will be 1.01 to the power of 2. 2 months. That's just for the 2 months that it's sitting, that you've got this loan, not making any repayments, which means that you're going to now owe $8,670.85. So it's increased, obviously. You're paying interest. Now, after these 2 months, we start to make payments. So this is where we start to build our series. I'm going to be starting the P that we're using, or the amount of money in our compound interest formula, is going to be the 8,670.85. And the N is going to be for the remainder, which is the 58 months. Okay. I'm going to start again with A1, because this is just saying from the first month where I make a repayment. All right, I do know that 2 months have already been used, but it just makes it easier if you start at A1 again. Okay, so using my process, I start the month owing $8,670.85. I get charged interest at 1.01, and then I make a repayment. So I subtract off an M. Moving on to A2. I start with 8,670.85. I start with what I had at the end of the first month, but I have to put that in brackets and times it by another lot of interest, 1.01, and then make another payment. If you expand that out, you get 8,670.85, and 1.01 squared. You will then get minus 1.01 m minus m. Do we want to do A3? Oh, okay. All right, how about we factorize out the m? So minus m, starting with the 1, we would have 1 plus 1.01. And you could generalize the A3, but you guys told me you didn't want to do that. All right. Skipping through then. We've got A1, A2. We've got enough to see our series happening in there. So we're going to skip down to A58 and get our pattern, 8,670.85, 1.01 to the power of 58, minus m, and then 1 plus 1.01 plus ... all the way up to 1.01 to the power of 57. Okay, but A58 is equal to 0, so we can then solve for m. So bring the m across the other side and add the series. Oops, needed some dots in there. Okay, summing the series, A is 1, R is 1.01 to the power of 58, minus 1 over, I'm just going to change it straight to be 0.01, subtract the 1 straight off it. Okay, and then to get the m, it's lots of rewriting. I know it's annoying, but you do have to be able to build it. They do require that. So we're going to times the 0.01 up, then we're going to divide by the 1.01 to the power of 58 minus 1. And what do we get? Should get 197.75 as your monthly repayment. It's good to make sure you look at your question and go, is that realistic? Like if you're getting a massive number at the end that's like nearly as much as your loan, it's probably not realistic. Okay. Part C, how much does he pay back altogether? The loan was 8,500. Let's see how much he actually pays. He paid 197.75 every month for how many months? 58, because he didn't pay for the first 2. So 58 months, and when you times that together, he paid 11,469.21. So there's an extra $3,000, $3.5 nearly, that he's paid in interest. All right.